in the deep ocean and strategies to maintain the integrity of deep ocean ecosystems within and beyond national jurisdictions. The purpose of this particular event is to communicate the importance of the deep sea, its connection to climate change, and to express the thoughts of the next generation in deep sea science. First, we're going to be hearing from our wonderful speakers sitting over here. Each person's going to give about a 5-minute presentation, and then we will have a panel discussion with a Q&A session. And at the end, we will be giving away stickers made by Olivia Pereira, so make sure you stay for that. She's got some great deep sea animal stickers. Okay. So our first speaker is going to be Michelle Garay. She is a master's student at Scripps Institution of Oceanography at UC San Diego, but Michelle is originally from Mexico. She studies animal communities living in the deep sea benthos, that's the seafloor, and their adaptations in low oxygen environments. Michelle.
Thank you, Lisa. Can you hear me well? Well, good evening, everyone, and good morning or afternoon to those of you watching live. I want to start with a question for those of you who are here present. How many of you think that you are connected to the deep ocean in some way? You just raise your hand. Wonderful, a lot of you, that's great. So we're here to talk about the deep ocean, right? And I want to tell you why the deep ocean is so important. When I think about the deep ocean, I think about its mysteriousness and its beauty. And perhaps you think so too after having watched that video that was playing as you were taking your seats, or by looking at the photo that I'm going to show you. This photo. In scientific terms, the deep ocean is the region that is greater than 200 meters deep. This habitat comprises 2/3 of the surface area of the planet, so it is safe to say that it is the largest realm on Earth. The deep ocean is very unexplored because it is vast and remote, so most of its characteristics remain undescribed. So you might think, why are we here talking about this remote place on the planet that is so hard and expensive to access? And the reason is simple. Very simple, actually. The value of the deep ocean is immeasurable. The deep ocean harbors a remarkable diversity of organisms. It provides a wealth of societal benefits, and it is important because it provides many processes that allow this Earth to be full of life. So I want to talk to you about some of the characteristics of the deep ocean that make it so important. First, its heterogeneity, both on the seafloor and the water column. For example, the seafloor is full of different ecosystems. There are thousands of miles covered with abyssal plains. There are tens of thousands of underwater mountains called seamounts or underwater volcanoes. There are deep sea canyons, there are deep sea reefs, hydrothermal vents, and cold seeps. And the water column is also full of heterogeneity with different nutrient and oxygen concentrations. So the combination of all of these different habitats creates a lot of different conditions for so many animals to exist. Second, the deep ocean regenerates nutrients which are key to the production of organisms in surface waters. This eventually provides a lot of food for fisheries. Third, the deep ocean slows down the warming of surface waters and land, and is mainly the reason why life on Earth is possible. We know that the ocean is absorbing about 90% of the heat that we have released because of fossil fuels. And last but not least, one of the most important functions, and perhaps the most relevant today at COP, is the ability of the deep to sequester carbon. The ocean has captured 1/3 of the carbon that we have released into the atmosphere by the burning of fossil fuels. So the ocean really provides a lot of services to humanity. So now that you know why the deep ocean is so important, perhaps you want to know more about its relationship to carbon storage and sequestration. So let's hear from our next speaker.
Is this on? Anybody here? Okay. I'd like to welcome our next speaker, Dr. Nerissa Bax, who's from New Zealand originally, but Nerissa works as the Marine and Coastal Program Coordinator at the South Atlantic Environmental Research Institute in the Falklands, right? Doesn't say that. And she specializes in seafloor biodiversity, conservation genetics, and blue carbon with a particular focus on the sub-Antarctic and Antarctica and on deep sea corals. She formed a policy science collaboration for the protection of Antarctic blue carbon in 2020 that is recognized as being in the top 5 of all research measured by altmetrics. Nerissa.
Thank you so much, Lisa. What I wanted to open with here was actually a quote. I've seen that a lot at COP27, and it's been quite a nice thing to, see why we really care, right? And so the Tasmanian author Richard Flanagan, he penned a beautiful tragic sentiment a few years ago, stating that we live in the twilight of things, granted one last glorious vision, unequal to even bearing adequate witness to the wonder that is vanishing. And I'm going to talk to you briefly about one of the many known reasons the deep ocean is essential. One of the many aspects of the oceans that we need to preserve, its capacity for carbon storage and sequestration, termed blue carbon. But like the quote, there are so many reasons to protect the deep ocean, some that we are yet to even realize. In the broadest sense, blue carbon is the capture of CO2 into the tissues of plants and subsequent storage in animals. This provides a biological pump for this carbon to be sequestered into sediments. And the figure here from our 2020 paper visualizes carbon capture, storage, immobilization, and sequestration across time. When marine animals die, some of the carbon is stored in their bodies, and skeletons can be buried in seabed sediments. What's important here is that this removes the carbon from the carbon cycle. This long-term removal from the carbon cycle is genuine sequestration, and in Antarctica we are finding that this ecosystem service is forming what is known as a negative feedback on climate change. So it is working against, slowing, buffering us from the worst damage. And there are 3 key aspects to this work that make it so important. So the area is vast. The Southern Ocean encompasses a 1/16 of the total ocean area on Earth. The sequestration time frame is long, hundreds to thousands of years, potentially even more. And importantly, the capacity is increasing with warming and ice melt. Okay, so both of my videos don't work, but this slide is talking particularly about a graphic that we have from South Georgia. So South Georgia is an island between the Falklands, where I live, and Antarctica. And it is a location that you can see is particularly, this is nice. This is my final one, actually. Maybe I should just leave it on this. And so South Georgia is this illustration of the contribution of biodiversity as blue carbon, and without the driver of ice and loss. So in the graphic that I had, you see through time glaciation over thousands of years, and there is this area below the ice scour around 500 meters, and this is actually an area where this image is taken from, where these deeper areas and islands like the Falklands form refugias. And so this means that we have some of our oldest, most intact, ancient biodiversity in these realms. Who here is from an island? Nice. So I'm originally from New Zealand, Aotearoa, and across my career I hold a strong affinity for islands. In the last decade, particularly islands that act as gateways to Antarctica, such as Tasmania at the bottom of Australia and the Falklands, where I currently live. It's probably the only place in the world where someone can live and see the subantarctic ecosystem change throughout the year. This is a location that hosts high biodiversity with linkages to the Antarctic and Atlantic. And time and ice is an important part of this story. If you look at the graphic, it illustrates how animals colonize new areas and open up as sea ice recedes. It also illustrates high biodiversity below the region of ice scour. So the beauty on the seafloor is this area of the deep sea, the coral fields, which is featured here, is what inspired and continues to inspire my career. And our research largely focuses on what is known as vulnerable marine ecosystem indicator taxa. So these are animals like corals, sponges, bryozoans, and brittle stars, which have calcium carbonate skeletons, making them particularly vulnerable to change, and they are slow-growing, long-lived, and late to reproduce. They are considered at risk of direct threats such as fishing and comorbid impacts such as ocean acidification and warming. And vulnerability is the key aspect here. So it's the vulnerability of the animals, but also the vulnerability of the carbon stores. Sorry, I'm up to my last bit. And so to consider, so in terms of blue carbon, it's important to consider these areas that are beautifully biodiverse, but also where animals go to die. And it creates a much more nuanced aspect to incorporate into marine protected areas. And the threats, not only to this visual beauty that we see, but also to other areas as well. And the next speaker will elaborate on that.
So our next speaker is Dr. Sarah Seabrook, who is an oceanographer at the National Institute of Water and Atmospheric Research in New Zealand. Her research focuses on understanding how changes in the ocean environment impact the structure and function of ecosystems. And central to this work is the determination of what changes in the ocean environment mean for society now and under future climate scenarios. Sarah?
Thank you. I grew up in the Gulf Coast, nearby the Gulf of Mexico. I spent probably half of my childhood underwater, swimming around, and the Gulf was really my escape from summer heat. It was my way to explore emerging curiosities about the world and the ocean, and my way to dream and imagine about what might exist beyond the horizon. The Gulf seemed vast, resilient, and full of abundant life. When the Deepwater Horizon disaster occurred, claiming 11 human lives immediately, and billions, if not trillions, of other animals in the years that followed, my view of the ocean and our relationship to the ocean changed dramatically. Before this catastrophe, I didn't even know that we had hundreds of oil rigs off of the coast or about the impacts that these activities can have. But I quickly learned. Over 3 billion barrels of oil leaked into the ocean, and many life forms were smothered. And these impacts can still be found if you go down to these areas of the ocean now. Many organisms can be found either covered in oil or still struggling to try and feed and live and reproduce in an environment that has this amount of contamination in it. And this impact, it didn't just stay in the deep sea. It washed up on our beaches. It poisoned the water that we swam in and that we fished in and that we had as part of our livelihood. It closed down tourist and fisheries industries, and it caused economic impacts that lasted for years. And this isn't the only impact that is felt by the deep sea and by humans. Heavy fisheries and through trawling that's caused by fisheries, it has impacts on the ocean that's similar to rainforest removal on land. Deep sea mining could cause the extinction of species we have yet to discover and impact important ocean processes. And these impacts are not individual. They can occur together, and they all occur under the umbrella of climate change. These cumulative stressors cannot be ignored, as they are pushing the ocean to a tipping point with irreversible change that could hinder the ocean's ability to mitigate climate impacts as it has done for all of human history. Human impacts in the deep ocean are often out of sight and out of mind until they are not. We will all be impacted by what happens in these remote places eventually, and it's our choice here at COP27 and beyond if we want to create the actions and change necessary to have a more sustainable and productive future. Thank you.
Thank you, Sarah. Our next speaker is Dr. Isa Olalekan Elegbede. He is an adjunct professor at the Department of Environmental Sciences, National Open University of Nigeria, and a full-time academic at the Fisheries Department at Lagos State University in Lagos, Nigeria. Isa serves as the co-chair of the GeoBond Blue Planet Fisheries Working Group, deputy chair of the IUCN CESP and TGER Switzerland, and is a fellow of the Future Earth Coast. Isa.
Thanks so much. Today we'll be talking about blue economy and climate concerns, including relationship with the deep sea resources. Yeah. So globally, we see that humans have been depending on the oceans, and this dependence has been based on focusing on opportunities such as trade, tourism, including research and energy. However, according to NASA 2022, we've seen that blue economy is worth around $2 trillion yearly, and with this, humans are still pursuing and exploring these resources. Hence, so the deep ocean resources has the capacity to absorb abundance of heat and carbon dioxide, acting as a buffer to the system. But this situation still affects biodiversity and even jeopardize benefits that humans are supposed to derive from the ocean. Now you can see the component of blue economy, as seen in the slide. humans has been able to extract living resources, including non-living resources, and as well to explore trade and commerce through the ocean. And these ocean resources can be explored through coastal, through coastal, the EEZ, and the deep sea. And we can see that the deep sea has the capacity to supply fish resources, chemicals, including seabed mining for minerals, shipping, and cruises. And all these are based on drivers of humans to benefit from this environment. As you can see from this, from the next slide, you can see the benefits that the ocean, the deep sea resources could give to humans, and which include supporting services, provisioning, giving services such as cultural, regulatory services, and as well, all this entails giving education, food resources, energy, and as well, waste disposal. However, the climate drivers for the deep sea ocean has been enormous. We've seen cases whereby chemosynthesis has been affected by the increase in temperature and as well reduced oxygen. And we have also seen where canyons and various ecosystems in the deep sea environment has as well been decreasing the oxygen in the environment. Likewise, we've seen cases where there are rises in temperature that has as well reduced biodiversity in the ecosystem. So based on this, we are agitating, based on the instrumentations with the COP27, that there's need to mitigate and to have strategies towards having a blue economy with the deep ocean, and which include trying to meet up with the agreement, with the Paris Agreement, so that we can reduce the impact on the ocean, and likewise to have open data that will be explored with having observation systems. And we implore all stakeholders to involve others, including the inclusion in all these aspects. Likewise, having researches that will be able to fill gaps in science. So lastly, we have seen that there is need for increased ocean literacy in all sectors, including all ages. We are also clamoring that we should have deep sea and ocean knowledge down from elementary classes. Likewise, all states need to support in terms of supporting climate issues, and as well need to reduce greenhouse gas emissions. However, it is important to also know that there's need to ensure inclusion in the UNFCCC process, and likewise to strengthen policies through having sustainable resource management within the areas beyond national jurisdictions. So thanks so much for this presentation. So I will invite my next speaker. Thank you.
Thank you, Issa. And our last speaker, with at least the last formal presentation, is by Olivia Pereira. Olivia is a PhD candidate at Scripps Institution of Oceanography at UC San Diego, but she's originally from Brazil. Her research focuses on hard substrate macrofauna at bathyal depths, examining community dynamics and resilience in the context of climate change and other disturbances to the deep sea. Olivia is also conducting interdisciplinary research incorporating economic approaches to value the deep sea and its ecosystem services in order to provide insights and guidelines for management and conservation efforts.
Hello, everyone. Thank you, Lisa, for the introduction. So you've been hearing all about why the deep sea matters because of all the things that it does for biodiversity, but also for us. And this is what we call ecosystem services. Ecosystem services are benefits to humans provided by the natural environment. And like Isa mentioned, they're categorized into 4 groups. So we have the supporting services, which are those necessary for the production of all other ecosystem services. They're also called they're also called ecosystem functions. So things like nutrient cycling, productivity, nursery, habitat, breeding grounds, refuge, connectivity, dispersal. Those are all examples of supporting services. We also have provisional services, which are products. They are raw materials that we can get from the deep sea, like fish, like pharmaceuticals, and all the biomedical potential that we find in the deep ocean. We also have regulating services, and these are benefits from the regulation of environmental processes, like climate regulation and carbon sequestration, like Narisa was talking about, and also biological control. And finally, we have cultural services. So these are non-material and non-consumptive benefits, what we can also say the non-use values of the deep sea. Things like aesthetics, existence, education, and inspiration. And I want to focus on those cultural services. So first, the deep sea has a great potential for education. So we're constantly discovering new things in the deep sea, and it's important that we keep educating people and training the next generation. So in these photos, you're seeing me and Michelle on research cruises. And personally, coming from Brazil, I feel very fortunate and privileged to be studying the deep sea ecosystems and to have access to the high technology, like in those photos, like submersibles, that allow us to do the work that we do. Especially coming from Brazil, like I mentioned, where there's less access to these resources, but an incredible deep sea off our coast. And this is the education that I also want to talk about. I want to see more equal opportunities for everyone, especially in the science education sector. And education is not only about training the next scientist, it's also bringing the knowledge to the public. One way that we can do that is through science communication. So for example, I do science communication on Instagram, but there's a lot of people that also use other social medias to do that. And something else that is getting really huge in the deep sea is telepresence. So institutions like Schmidt Ocean Institute and NOAA have been broadcasting the dives from their ROVs or the submersibles live from deep sea cruises, and people can watch from their couch and talk and ask questions to the scientists that are at sea. The deep sea also serves as inspiration. You might have heard that James Cameron went down to the Mariana Trench to get inspiration for his next Avatar movie. A lot of things in Avatar, like the bioluminescence, comes from the deep sea. We also have the anglerfish in Finding Nemo, which personally was what got me into the deep sea. And we also have the alien, the xenomorph, that people say that was inspired by the deep sea barrel-riding amphipod. But it's not just movies, it's also art. We've been inviting artists, journalists, photographers to come to sea with us so they can document what we are saying and doing that in the form of art. And of course, I have to talk about cultural value and traditional knowledge. For the deep sea, traditional knowledge is manifested in the preservation and perpetuation of connections between people, species, ecosystems, and processes. It embodies cultural and spiritual values associated with the natural environment and an important and respectful interaction with nature. Yesterday, at the Deep Rising event, we heard someone mention an African saying, "Our ocean is sacred. You can't mine heaven," which was the slogan of an exhibition that invited people to a public dialogue into how decision-making should take place. Traditional knowledge may have their own customary decision-making processes, and they should be incorporated in management and decision-making through meaningful engagement and involvement. And lastly, we have the existence value. As part of my PhD research, I'm studying what people know about the deep sea, what they value about the deep sea, and how much they value it. And as part of that, I've been reading a lot of past studies that have done that kind of research. And almost all of them, included mine, conclude that people care about the deep sea because of its existence value, because of the animals, the biodiversity, the endemic species that we only find in the deep sea, the habitat that it provides, rather than for its physical resources that we hear people talking about, like deep sea mining. People do care about the deep sea. And I'll say that again. People do care about the deep sea. because it has a right to exist, because it exists, and for our future generations. Thank you.
Well, thank you to all our speakers for those amazing words of wisdom and for your passion, clear passion about the subject. We have a question that we're going to ask all of the panelists to discuss, and then we'll open it up to the audience. So we have asked each person to think about what role they see. No, that's the wrong one. Okay, so we're asking each person, what do you hope to see in the future as the next generation of deep sea scientists and communicators? Who would like to go first?
So I knew this question was coming, and my original feeling about it was that I wanted to wish people more time. But in the context of thinking for the next generation, I feel like the next generation is already there. And something that I feel a lot with us working in somewhere where it is so expensive, so remote, so difficult to access, is that so much of our time and energy is focused on creating the conditions to get to the point where we can do something that is applied and that matters and that results in real on-the-ground conservation. And so what I want to see is that the conditions are created so that the generation of scientists can get on with the work that really needs to be done.
Thank you. What I would like to see for the future of the deep ocean and future generations going in this field is the more conversations about how the deep ocean is related to climate change. I think when people talk about climate change, they rarely mention the deep ocean, and it really is a very essential part of this planet that, because people don't think about it, because it's down there, it's not right in front of you, then it's not really in the conversation. And we really need to start talking about the deep ocean when people talk about climate change, because the deep ocean is providing so many services and affecting the climate so much. And for example, right now with deep sea mining in the conversation, we really need to understand that deep sea mining is not a solution for climate change. And I feel very strongly about that. And I think we really need to start talking more about this and stop saying that we need to mine the deep ocean to decarbonize the economy. If we really think that, we should really do the research and understand if that's actually the case or not. I think we really need to go deeper into that before we can say that we really need to mine the deep ocean to decarbonize the economy. I think that's a big statement, and we just need to have more conversations about it, get more involved, understand more the topic before we can say that, because mining the deep ocean could have a huge effect on the climate and actually perpetuate it instead of solve the problem. So we just need to have more conversations and have more people involved in the topic. So I think that's what I would like to see in the future.
Yeah, thanks so much. From my side, I would like to mention that to have a generation of deep sea resources, it is important to see how we can start ocean literacy from elementary schools. And as well, from my colleague talking about traditional knowledge, there's need to have inclusiveness in bringing everybody on board, leaving no one behind, according to the Decade of Action conditions. So all this will enable to have the next generation to be inclined to protecting, managing, and having stewardship foresight towards having values around deep sea resources. Then looking at the blue economy. Now, the blue economy, talking about the attributes of exploring ocean resources, however, in a sustainable way, and as well protecting these resources. So there is need for all stakeholders to be conscious on how to explore these resources so that the next generation will still have it even better than it was before. Yeah, thank you.
Thank you for that. That was really good. I think that, and I was trying to I think I was starting to hit on this in the talk that I just gave, but I think it is really, really important for us to recognize as a global community that everything is interconnected. When we're thinking about the climate crisis, when we're thinking about the deep sea, it's a human problem. All of it's a human problem. We humans, we've evolved in a very small window of conditions on Earth, and everything that we do that pushes us outside of that window matters. And so if we are doing something in the deep ocean, while it might seem far away from us, it might seem remote, if we're doing something that's impacting people on small island nations, and it seems far away from us or remote, it's not. It will all affect us sometime. It's all interconnected, and we should care about all of it now.
I think that my answer builds up on what everyone said. I agree with all of that. And I think that for me is also what I mentioned about equal opportunities for everyone. I think that if we look at a map of how much science, deep sea or ocean science is being done in the global north and the global south, you're going to get shocked at how little is being done in the global south compared to the global north. And I think it's coming from the global south. It's something that I would just like to see happening more. I would like to see more of the opportunities, more of these high technologies that we have here being used also by the global south. And I think that also the deep sea science community is an incredible community. We do a lot of collaborations across institutions, across different countries. But I think that we need to go one step further. I think we also need to start getting connected to the outside of the science. So we need to get more connected to the policy people. We need to get more connected to economists. We need to get more connected to activists, NGOs. I think we need to start thinking, like Sarah said, that everything is connected. It's one deep ocean. And I think that we all should start seeing it that way, and we should all start having more conversations and being more connected, just like the deep ocean is connected.
Thank you guys for those really thoughtful answers. And I mean, for me, it's very exciting to see what the next generation of deep sea is hopefully going to look like, deep sea science. So I'd like to open it up now to our audience to ask the panelists questions. Anybody out there with a question? She has another. Great.
Hi, I have a question for you. So you were mentioning what is not done in the global south and reaching out to policy people. So I used to take maritime security class back when I was at uni. And I remember one of my fellow students who was from an African coastal country, she was saying, she was basically saying, like, my country has so much, like, urgent problem that what's happening in the sea, like pollution or whatnot, it's hard to prioritize. So I'm wondering, on the policy level, how would you convince these countries who have so much like urgent issues that it's also urgent?
That is a great question. I think that also coming from Brazil, we also have so many issues happening in Brazil in the last 4 years that it is hard to think, how am I going to tell my government that they should pay attention to the deep sea while my country is falling apart? And I think it comes to that point that we have to talk about the deep sea and show people how important the deep sea is. So the deep sea is connected to climate regulation. I think one huge thing that is happening in all countries, climate change is a big deal, is a major concern to all the countries. And the deep sea is associated with climate mitigation, carbon sequestration. It has a great potential to help in the climate fight. So I think we can go that route of trying to show people how important and relevant the deep sea is, because the deep sea can be, I don't want to say a problem, but deep sea mining, for example, can release more carbon and make things worse. But protecting the deep sea is actually going to help us. So I think we have to think about that and go in that route of saying the deep sea is also very important because it can actually help us. I don't know if that answers your question, but.
Yeah, thanks so much for the question and for your contribution. In addition, I would like to say it is certain that regions from the global south require support. For example, recently we had a program in Nigeria to talk about exploration of the deep sea resources. And what we are saying is, before you go to explore and damage the bottom resources, because you can as well get so many minerals in the terrestrial environment. So we should have information, data of the biodiversity values in these resources before we go there to damage these resources. So in essence, there is need to gather support, partnership, and collaboration linking between the global north and global south so that we can have research, awareness, knowledge, and as well merging between traditional and Western knowledge to be able to solve this problem so that we can have available data for the global south. Then we can be able to say these are what we have in our resources, and as well we need to protect them and we need to have adequate stewardship of these resources. Thank you.
Okay, more questions from the audience? Anything you're burning to know about the deep sea?
Hello. During your discussion, you mentioned that it is really important as science communicators to not only exist within this space of discussion, but to connect with policymakers, to connect with activists, to build a movement that can actually achieve the goals that are backed by the science that you're communicating. In what ways can you build meaningful connections with the members of the public, the institutions that support them, and actually get to conserve the ocean for climate action, for environmental preservation, to invest in our oceans to create a more prosperous future for humanity?
Anybody want to tackle that who hasn't?
I can tackle it in regards to the Antarctic blue carbon work in some regard, because Antarctica stands out as, like the deep sea, but it is for all of humanity, and there are many countries that are signatories to the Antarctic Treaty, for example. And so our paper proposed linking the Antarctic Treaty System with the UNFCCC and paving the way for nations to invest in protecting blue carbon. And we're looking at trying to quantify that into terms of CO2 equivalencies, for example, and putting that forward so you have an economic argument for protection as well, and one that can be collaboratively agreed upon.
I'll add to that as well. I think in thinking about how to connect with people, with policymakers, with anyone about the deep sea, one of the things that's so striking to me always is the imagery from the deep sea. You know, every time, like, we're very lucky as deep sea scientists, we've gotten to see with our own eyes these really amazing ecosystems. And you can be descending through dark ocean, not seeing very much. You can come upon the seafloor and just see crazy life everywhere, life that you have never imagined in your wildest dreams. The strangest forms of animals, the strangest forms of life. And that's really, really special. You know, that's something of the movies, but it's in real life and it's in our oceans. And so being able to capture that imagery and share it, I think, is a really important way and a really vital way of connecting with people about what's important in the ocean.
I think that there's also I don't know if you heard of the Deep Ocean Stewardship Initiative. DOSI is a network that includes all the different stakeholders. So it's scientists, is economists maybe, law. Okay. And DOSI, the idea behind DOSI is to try to create this connection between all the different stakeholders. So one of the things that DOSI has done, for example, is write policy briefs. And through those policy briefs, we can try to reach the policy-making people. So that's one way that we can try to reach that further from the science. Another way that I can think of also is science communication, but partnerships with other institutions or NGOs, or for example, I see people in the back with the Sustainable Ocean Alliance. On my Instagram, I've done posts and tagged them. They sometimes repost what I post. So this is also another way of reaching people, reaching NGOs, reaching activists, reaching the youth, and try to get those voices to also help us reach the policy-making people.
Yes, thank you. In addition, I will like to recommend that there's need to begin introducing ocean knowledge right from elementary classes, like I mentioned in my presentation. As well, the possibilities to explore beyond the usual mode of communication, such as movies, even movies, dramas, down to sports, including having arts, and as well talking beyond this environment, and as well bringing this information down to the local people, because we have people that might not be literate and that might not have the opportunity to be here seated with us. So we should as well translate some of this knowledge to various languages so that we can reach out to the deepest part where people live and they can get the information. Thank you.
One last word on that question. I just want to mention that also the power of photography. Photography has a huge impact on people, and it's a great way to showcase the different problems that we're facing in the planet. And I just want to mention that there's a documentary coming out in 2023 about the deep ocean and about deep sea mining. It's called Deep Rising. So look out for that as well.
We have some more time, so we're happy to entertain any more questions from the audience.
Hello? Okay. Thank you all for all of your answers. I guess bringing it back to this deep sea mining topic, I know a lot of people have talked about the need for those minerals for electric vehicles, for helping to combat climate change. Could you chat about the sort of pros and cons of land-based mining versus deep sea mining, since both of those would have sort of negative environmental impacts associated with that, and if it makes sense to sort of like comparing them to each other, which one is a bigger concern?
So, I mean, I'm not an expert on, compare, so he's asking how does the impacts of land mining versus deep sea mining, what are those, what's the difference between those two? So I'm not an expert on land mining and all the impacts. I mean, I know a few, but I think the main thing that I can think of is the fact that land mining has been happening for many years, and we know how to handle it in certain ways. I mean, of course, it's not great, and it is damaging the environment, but we know way more about how to do that. Compared to deep sea mining, we really have no clue what the repercussions of deep sea mining are in the long term, especially. So we're dealing with too much uncertainty and too much at stake because of all the services that the deep ocean provides. So I think that's one of the main differences between those two. don't know if anyone wants to add anything else.
I can just speak to a little bit the biology behind the animals that live in the deep sea. They are long-lived, they are late to reproduce, they are slow-growing, there's high endemism, and it's just in terms of, I think, what we all care about so much is if you take any of that away, you don't get it back. It's irreplaceable.
I think it's a tricky thing, when we talk about these differences and the impacts that are happening on land versus in the deep sea. One big reason why deep sea mining really should be taken with caution is the scale of impact. At a session yesterday, the statistic was given that I think the biggest land mine is 15 square kilometers, whereas in the ocean, if deep sea mining were to occur, it'd be 3,000 square kilometers. And so that's a very big difference in how big of an impact could be had on the area. And I think we also shouldn't just see it as a land versus sea. There's the option of recycling the material that exists already, and there's the option of thinking of new battery designs, which are already used in some places that don't need these metals that would be mined for.
Yeah, so the impacts in mining deep sea are enormous, even compared to terrestrial environment, because we've seen cases whereby exploring the deep sea resources affect various parts of the ocean, including the various food web and all attributed food chains. And we have as well seen whereby fisheries will be affected, and human living in the terrestrial environment still consume some of these resources, the fish resources. So it's a two-way thing. We will be affected in various forms, especially talking about the theme of this panel, the next generation. It is possible that the next generation will have nothing to go if the deep sea is exploited in a way that those environments are polluted.
One more thing. What Sarah said about the area size is one thing, but it's also, remember that the ocean is connected. Everything is connected in the ocean. It's just one big, deep ocean. And we don't know what's going to be the influence in the surrounding area. So that area is already larger, right, than terrestrial mining. But if you stop to think that that is not all, because all of that, the plumes or all the consequences are going to go further away from the area. And it's not just the mining area that is going to feel it, but it's also the whole entire surrounding deep ocean.
So I know I just listened to a podcast on this, so please do not quote me 100% because it was a week ago and I haven't slept since then. But I do know that a lot of land mining also, especially for things like magnesium and cobalt, do use often like forced child labor, which is why it's also just as contentious. I'm not advocating and being like, no, it doesn't matter. We can just vacuum the oceans. I'm not saying that. My question really comes out of that is, are you trying to couple your arguments for making sure that we're researching the oceans and doing more of that, and also really knowing what we're getting ourselves into for deep mining? Are you coupling those arguments with alternatives to the reasons why we think we need to mine the ocean? Instead of, because we keep saying electric vehicles, are we also promoting other options like public transit instead, and trying to shift away from that and towards actual solutions that don't require us to mine the oceans?
I think it's a little bit of what Sarah said, of trying to, also someone at the session yesterday said that the minerals are out there. You know, you can reuse, recycle. Yes, recycling those minerals might be super hard, but it is an option. I think it could be another way that we can go around it, at least while we make sure that we have the science that is needed.
Yeah, I think the answer is really innovation. You know, we are very resourceful and we need to be. We can come up with solutions to problems if we have to. We saw that during the pandemic. You know, we were able to make a vaccine very quickly on standards of what we normally produce. And I think it's there's a lot of options out there. It's not black and white, and we have a lot of resources we have already dug up that could be used for solutions to the problems without having to mine for new resources.
So we do try and get at some of those arguments just in terms of, you know, trying to understand that it's so much more valuable to keep what we have in the context of climate change. And in comparison to some of the solutions that we are trying for, right, like carbon capture is at present something that is relatively ineffective and very expensive. Whereas the animals on the seafloor, the services that they provide for us, they are doing for free. There is no additional cost other than keeping them there to continue to perform that service.
Okay, we have come to the close of our hour, and first I'd like everybody to give our very inspiring speakers a hand. We have a raffle. For those of you who came in late, are there still some, we're raffling away some deep sea stickers created by Olivia. And I think, is it, if they have a star, what is it? A heart. Okay, let's let everybody get one first. Did anybody get a heart? Raise your hand. 1, 2, 3, I think. Are there 5? Are there 5? You can get. We have. Do you have a heart? No. Okay. Well, come up and get your stickers. The 3 of you have a. Oh, maybe they left. All right. Well, what do you want to do with the other 2? Who's really dying to have a deep sea sticker? Right there. The people who ask the questions, maybe. So this is artwork by Olivia Pereira. Classic deep sea organisms. And shall I just thank everybody else? I'd like to thank you all for coming, and hopefully you've been inspired hearing about the deep ocean.